Now that you've gotten a basic SaaS app off the ground, so to speak, it's time to dive into some of the more sophisticated mechanisms to support more complicated apps. In this module, we're going to talk about a handful of such mechanisms, but probably the most prominent is associations. An association is a relationship between different kinds of resources in your app. For example, if we're going to enhance Rotten Potatoes to allow users to leave reviews of movies, and we might say that a given movie has many reviews, and a particular review belongs to exactly one movie. Furthermore, for a particular moviegoer, we might identify which reviews have been written by that moviegoer. So a review also belongs to a moviegoer, and a moviegoer has many reviews. Like many SaaS frameworks, Rails uses a relational database to store each model's data. And fortunately for us, the relational algebra that defines the operations possible in relational databases gives us a way to express these kinds of associations using foreign keys. A foreign key is just an attribute of one record in a database table that refers to the primary key of a record in some other table. For example, a row in the reviews table, which refers to one review, might include the primary key of the row in the movies table that review is about. So what's noteworthy about how this machinery works in Rails is that it's a great example of how a language and framework can work together to provide a useful abstraction that's easy to program against. As we'll see, Rails allows you to write Ruby code that behaves as if a single instance of a movie object holds a reference to an array of review objects that are associated with it. But in fact, the reference is not to an array at all. It's actually a reference to a different kind of object that looks, walks, and quacks like an ordered collection. So Rails takes advantage of three features of the Ruby language to define these so-called association methods. First, it uses metaprogramming to define methods at runtime that allow the associations to take place. Just by declaring that a movie should have many reviews, we can now dereference the reviews collection associated with a particular movie. Second, duck typing is used so that you can treat the collection of reviews as if it were an indexed array, even though that's not actually how it's stored or manipulated. And third, lazy evaluation is used so that the enumerable collection you think you have doesn't even exist until the very last possible moment that the database query can be deferred to. And at that moment, the appropriate SQL query is generated by Active Record to read from the database. As we'll see in the module on design patterns later on, this is actually an example of a design pattern called the proxy object. But the upshot of all of this is by adding just a few lines of code to your app, you automatically get machinery that lets you manipulate models in your relational database as if they were a graph of objects in memory. Of course, the ability of foreign keys to set up those relationships in the first place is one of the great features of relational algebra and relational databases. Remember that the next time that a colleague is singing the unvarnished praises of NoSQL databases. Now, you've probably heard the saying, if something is too good to be true, or sounds too good to be true, it probably is too good to be true. And sure enough, the abstraction provided by Rails for associations isn't perfect. When we return to monitoring and optimizing performance of SaaS apps in the module on DevOps, we'll see that like all non-trivial abstractions, active record associations in Rails are leaky. In other words, it's an abstraction in which some details of the implementation cannot be completely ignored in certain cases when you use it, lest you suffer some unexpected consequences. But, for the most part, associations are a great example of the heavy lifting associated with well-designed frameworks and how they can make it easy for you to write apps that adhere to its architectural pattern, which in our case is Model View Controller, by taking advantage of the features of the programming language in which the framework is written.